I'm going to work out the take-home quiz. It's the quiz that's in the book over at section 4.1 to 4.4. So let's start. And the first three questions are telling us that we need to evaluate whether this is a polynomial function. If it is, then we need to write it in standard form, state its degree, type, and leading coefficient. So for the first one, what I'm going to do is look at the leading coefficients. They have to be real numbers, no imaginary. 5, 2, -3, -2. Yes, they all are. Now let's look at the exponents. The exponents have to be 0, 1, 2, 3, 4, something like that. No variables, no fractions, and they meet that criteria. So let's put it in order of largest exponent to the least exponent. That would be a -3x to the fourth, then x cubed, then the x squared, then the x term, then the 5, so there's standard form. I need to find its degree. Well, the largest exponent is 4, so the degree is equal to 4. The leading coefficient is the coefficient in front of the term with the largest exponent. That would be a -3. And the type is, it's a fourth power, so it's a quartic. Let's look at the next one. Coefficients. 1/4, 2, -3, 1. Yes, those are okay. 3, 1, 2 for the exponents, that's okay too. So let's write it in order for standard form. It would be a -1/4 x cubed. Now I need the squared term if there is one. The x term. Okay, we can see that it is a degree 3. The leading coefficient is 1/4, and it's a cubic. Okay, the last one is not, look at the coefficients, 3, -6, 4, yeah, those are okay, but right here I have a negative exponent, so it's not a polynomial function. Let's go on. Okay, so here we have to describe where the x values say that the x values create y is increasing or decreasing. So I'm coming along from the left. And you can see that as I come along from the left, what I'm actually going to be doing is I'm going to be climbing upwards. So it's increasing for all the values where x is less than this value of x right here, which is 2. So it's decreasing for x is less than 2. At 2, it's not increasing or decreasing, it's flat. And then it's decreasing over here where x is greater than 2. So let's go ahead and put that increasing. That's when x is less than 2, decreasing when x is greater than 2. Okay, now the next part, it says, what this is saying is state the x values where y would be greater than 0. So we can see that y is greater than 0 for this area right in here. This is where the y value is greater than 0. And the x values that correspond to that. Now, the actual points, because it's not greater than or equal to, so these are like open dots there as far as this question is concerned, that you can see that as I go for x values between these two places, that's where the y values are actually greater than 0. So for part B, it's going to be where 1 is less than x is less than 4. That's going to create a y value that's greater than 0. Okay, for the C, the values that create, the x values that create a y value less than 0 would be out here, where x is less than 1. And also over here, we can see that y is less than 0, where x is greater than 4. Okay, write an expression for the area and the perimeter. Okay, so for the perimeter, let's go ahead and fill out some of these. The perimeter, this is x, so this is x. This side over here, if this is x plus 1 and this is x, this side has to be x, this piece, plus this x plus 1. This is x plus 3. And so I think we've got them all there, so let's simplify these a little bit. This piece here would be x plus 3 plus x, so that's 2x plus 3. Over on this side, I have x plus x, this will be 2x plus 1. So for the perimeter, I'm going to add all those sides together. So the perimeter is going to be the top, then the side here, now this small little x piece, this x piece, the whole side down here, and lastly I'm coming up this side, that's 2x plus 1. Okay, so that's going to be equal to x, 2x, 3x, 4x, 5, 6x, 7, 8x. So I've got 8 x's, 3 plus 1 is 4, 7, 8. So I have my perimeter as 8x plus 8. Now let's do the area. Okay, so for the area, I'm going to divide this in half and figure out the area of these two boxes. So for the box that's right at the bottom, that's going to be the area of this x side times the area of the length of the bottom. For the top box, it's going to be this side times the top. Okay, so I can say that the area is x times 2x plus 3 plus the area of the top piece, which is x plus 1 times x plus 3. So let's go ahead and work that out. This is going to be 2x squared plus 3x. Now this will be a FOIL, plus x times x is x squared, plus 3x, plus x plus 1 times 3 is 3. So let's simplify. Here's my x squared, a 2x squared and an x squared. That's going to be 3x squared. I have a 3x plus a 3x, that's 6x, plus another x is 7x, and 3. And so there is the perimeter, and there is the area in an expression. Okay, let's go to the next one. Perform the indicated operation. So the maximum degree I have here is a 2. So I have a 7x squared minus 3x squared. That's 4x squared. Then let's look for the x terms. There's a minus 5x squared, but look, there's a subtraction, so that would be plus 5x. Okay, so I've taken care of this term. I've got this term. I've got this term. Now I have a minus 4, and I have minus a plus 1. So that would be a minus 4 minus 1. That would be minus 5. Okay, let's do the next one. Now we're going to have to multiply this one. So I'm going to say this x squared by these two terms. So x squared times 3x. That's 3x cubed. X squared times a minus 1 is minus x squared. Let's move to the next term. A minus 3x times a plus 3x is going to be a minus 9x squared. The minus 3x times a minus 1 would be plus 3x. Now let's move to the 2. 2 times 3x is plus 6x. 2 times a minus 1 is a minus 2. Let's combine like terms. We have 1 cubic. I have an x squared minus 9x squared minus 10x squared. 3x plus a 6x is plus 9x minus 2. Okay, let's do the last one. Now for the last one, we're going to multiply these two together, get an answer, and then multiply that answer by this x minus 4. So let's do FOIL. So x times x is x squared. X times 3 is plus 3x. Minus 1 times x is minus x minus 3. And of course, all that is times x minus 4. Let's simplify this. X squared 3x minus x, that's plus 2x minus 3. Okay, now let's go ahead and multiply x squared times x, that's x cubed, minus 4x squared. Moving to the second term, 2x times x is plus 2x squared, minus 8x, and then a minus 3 times x is a minus 3x plus 12. Combine like terms. Okay, I've got one cubic term. I have a minus 4x squared plus a 2x squared, 8x and a 3x. So there's my answers. Okay, let's go down to the next question. This is factor completely. Okay, the first one is I have an a cubed, but I also have a common factor of a. So let's pull that out. And that would give me with a squared minus 2a minus 8. So now we still have to factor the squared portion. So I'm looking for two numbers that add to a negative 2 and multiply to a negative 8. Well, that would be negative 4 and 2. So I have a times a minus 4 times a plus 2. And even though I factored an a out, it still has to stay in this in the problem. Actually, did I miss a problem here? Looks like I did. I'll have to go back and get that later. It looks like it may be 10. Let's see what I got. 8. Yeah, I'm going to have to go pick those up if they're not in there. I'll do those at the end. Okay, number 12. This is going to be a sum of cubes. So let's go ahead and write the formula. A cubed plus b cubed would be equal to a plus b times a squared minus ab plus b squared. Okay, so in this case, a is going to be the square, or the cube root of 8m cubed. So a is equal to 2m. B in this case would be equal to the cube root of 27, which would be 3. So let's plug those in. So I'm going to have a plus b times a squared. Okay, so 2m squared, that would be 4m squared. Minus ab, that would be minus 6m. And lastly, b squared would be plus 9. Okay, the next one looks like it's going to be a grouping. There's nothing I could factor out, so if I have z squared, that would be z plus 1. And then I'll say I need to have a z plus 1 over here. And I'll take 4 out, minus 4. So what I'm going to have is z squared minus 4 times z plus 1. Now, I still have to look to see if I can factor the squared term, and I can. That's a difference of squares. So z minus 2, z plus 2, and then the z plus 1. Okay, the last one over here, as far as factoring, Let's take a look at that, and that's going to be a difference of squares, but it's in quadratic form. So if I take the square root of the first term, that's going to be 7b squared minus the square root of the second term, minus 8. And then I've got 7b squared plus 8. And let's look to see if we can factor any of these terms. This can't be factored. This may be a difference of squares, but no, it's not. So that's done. That's as far as I can take it. Okay, the next one says show that x plus 5 is a factor. So I'm going to do that by synthetic division. So if x plus 5 is a factor, then x would be equal to negative 5 would be the 0. So let's go ahead and do synthetic division on this. So I have a coefficient of 1 on the x cubed term, a minus 2 on the squared term, minus 23 on the x term, and 60 on the constant term. So I have all the terms, cube, square, 1, so yeah, they're all there. Don't have to add a 0, and I'm going to do a synthetic division with a negative 5. So 1 times negative 5 is a negative 5. Gives me negative 7. Negative 7 times a negative 5 is 35. That would give me a 12. 12 times negative 5 is a negative 60. And that gives me a 0, so sure enough, it is a factor because the remainder is 0. And what I have left here would be x squared minus 7x plus 12. So right now, my factors for that are I have x plus 5. That's what I started with, right? X plus 5. And when I divided by that, I have another perfect factor, x squared minus 7x plus 12. And I have to continue to factor, so I have x plus 5. And this two numbers that add to negative 7 multiplied by 12 is x minus 4, x minus 3. Okay, that looks like that's it. So let's go ahead and pick up the ones that I said I missed. I believe that number 10 is this. So let me do number 10. It looks like it's going to be 4x to the 4th minus 2x cubed plus x squared minus 5x plus 8 divided by x squared minus 2x minus 1. Okay, that'll have to be long division because look what I'm dividing by. It's not a simple thing like x minus 5, x plus 5. So let's go ahead and do that division. So I have 4x squared minus 2x cubed plus x squared minus 5x plus 8. And let's make sure, oops, let's make sure I have all the terms. And I don't have to add a 0. 4 cubed squared 1, 8. Okay, so I got them all. And let's a little more room. We're going to divide that by x squared minus 2x minus 1. Remember, you would have to leave a 0 space up here if one of these exponents is missing. So anyway, I'm looking for a number that multiplied by x squared gives me 4x to the 4th. That would be 4x squared, so I'm going to put that above the x squared column. 4x squared times x squared is 4x to the 4th. 4x squared times a negative 2x is a negative 8x cubed. And 4x squared times a minus 1 is a minus 4x squared. Now I'm subtracting this. So I have a negative 2 plus 8, minus a minus, so that's plus. That would be 6x cubed. I have 1 minus a minus 4. That would be 1 plus 4. That would be plus 5x squared, and then minus 5x plus 8. So now let's get rid of the 6x cubed. And I'm going to multiply by looks like a 6x. So that would give me 6x cubed. 6x times a minus 2x is going to be a minus 12x squared. 6x times a minus 1 is minus 6x, and we're going to subtract that. Okay, so 5 minus a minus 12. That's going to be plus 12, so I have 17x squared. 5 minus a minus 6, that's 5 plus 6, so I have plus x plus 8. All right, so now I need to get rid of that 17x squared, I'm going to multiply by 17. 17x squared minus 34x. 17 times a minus 1 is minus 17. I'm subtracting. So I have 1 minus a minus, that's going to be plus, so that's going to be 35x. And I have 8 minus a minus, okay, that's going to be plus, so that would be plus 17. And I can't divide into that, so that's my remainder. So my answer is going to be 4x squared plus 6x plus 17, and writing the remainder as a factor would be plus 35x plus 25 all over my divisor, which is x squared minus 2x minus 1. Okay, let's see, what one? Number 9, I guess I missed that too. So let me go ahead and do number 9. Number 9 looks like it's a binomial expansion. And it looks like it's x plus 2 to the 5th. So let's go ahead and work that out. Now, let's talk about the Pascal's triangle. So I'm just going to go ahead and write the third row. This is where n equals 3. And that would be 1, 3, 3, 1. So n equals 4 would be I have a 1 here. I have a 1 here. This would be 1 plus 3 is 4. 1 plus 3 is 4 and a 6. And then finally for my n equals 5 row, I'm going to have a 1 way out here. 1 way out here. I have 1 plus 4 is 5. I have 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So this is my row right here. Okay? Now, so my expansion, if I was dealing with a plus b, would be if I had a plus b to the 5th, that would be equal to 1, this 1 times a to the 5th, and then it would be plus 5 times the exponent would drop by 1, and b would go up by 1. Then I have 10 plus 10 times a cubed, b squared. Then I have another 10 plus 10 times a squared, b cubed. Then I have 5 plus 5a b to the 4th. And lastly, I have this 1 plus 1 b to the 5th. Okay, so for my particular one, I have a equal to x and b is equal to 2. So let's put those in there. So I would have 1. So I'm starting with the first term. 1 times a, which is x to the 5th, plus 5x to the 4th, and b is 2. Okay, and let's move to the next term. Plus 10 times a cubed, so that would be x cubed, and the b is squared, plus 10 times a squared, a is x, b is 2. Okay, now moving to plus 5 times the a term, and b, which is 2 to the 4th, and lastly I have plus 1 times b, which is 2 to the 5th. Okay, so for my first term, I'm going to have x to the 5th. The next term I have 2 to the 1st, that's 2 times 5, that's 10. Next term, I have 2 squared. That's 4 times 10. That would be plus 40 x cubed. The next term, I have 2 cubed is 8 times 10. That's 80. The next term, I have 2 to the 4th. That's 16. 16 times 5 is 90. No, I don't think it is. Let me check that out. 80. It's 80. And lastly, I have 2 to the 5th. And there's by my binomial expansion. And I think that's all the problems.